Welcome in. We're ready for another deep dive, and this time, you guessed it, we're tackling information theory. We asked for your input on this one, and wow, you guys delivered.
You weren't kidding. Some seriously foundational stuff here.
Right. Like, we've got Claude Shannon, we've got Warren Weaver.
Classic.
Absolutely. And get this, their work, some of it's from way back in 1948.
It's amazing how relevant those foundational ideas still are today. Back then, Shannon was an engineer at Bell Labs and
Okay, wait, 1948 Bell Labs, that's like the dawn of the information age, right?
exactly. And Shannon was right there on the front lines figuring out how to actually quantify this thing we call information, how to actually measure it.
Which is wild, right? Because we throw around the word information all the time, but we usually connect it to, like, meaning, stuff that makes sense. But Shannon's work, it kind of flips that on its head.
Absolutely. He wasn't so concerned with the meaning itself, at least not initially. He was more focused on the accurate transmission of symbols.
Okay, so, like, how we get the message across, regardless of what the message actually is.
Precisely. He called it level A communication. The nuts and bolts of how we send and receive those signals, leaving the whole interpretation part, figuring out what those signals actually mean for later stages.
Okay, I think I'm starting to get it, but give me an example.
Yeah.
Let's say you have to choose between two messages to transmit. Message number one, the entire text of the King James Bible. Message number two, the single word, yes. Now, most people would say, okay, the Bible, that's way more information.
Right. Tons of words versus chapters.
Exactly. But in Shannon's world, that's not always the case, is it?
You're on to something. In Shannon's framework, both the Bible and the single word yes could actually represent the same amount of information.
Wait, seriously, how is that even possible?
It all comes down to probability and something called a bit.
Okay, now you're just messing with me. Bits, like ones and zeros. What does that have to do with the Bible?
Think of it like this. The less likely a message is, the more information it conveys.
Okay, so the more surprising a message is, the more information it packs.
You got it. It's not about the sheer volume of content, but the unexpectedness of the message. That's what Shannon was interested in.
So a message telling me, hey, the sun rose this morning, that's not very high on the information scale, right?
Exactly.
Yeah.
Because we kind of expect the sun to rise every morning.
But a message about, say, a surprise snowstorm in July, now that's got my attention. That's packed with information because it's so unexpected.
Exactly. The higher the entropy.
Entropy. Whoa, hold up. Now you're taking me back to high school physics class.
Aha, I know,
I
right?
always thought of entropy like, messiness or disorder. What's it got to do with information?
That's where Shannon's brilliance comes in. He made this connection between entropy, usually associated with, like you said, disorder in physics, and the world of information.
Okay, I'm listening.
He realized that a key aspect of entropy, as a measure of the number of possible arrangements of a system, could also be applied to information itself.
So the more uncertainty there is about a message, the higher the information content. Like with that snowstorm in July, there's a lot of uncertainty, a lot of surprise.
Precisely. The higher the entropy, the more possibilities exist for a given message. And when we receive that message, we're gaining information because we now know which of those possibilities actually happened.
It's like those fill-in-the-blank puzzles. The more options you have for a word, the more satisfying it is to figure out the right one.
Exactly.
Which, okay, this is blowing my mind a little bit because then you get into this whole thing about redundancy in language, right?
Right.
Like with English, there's a lot of it. We can often guess the next letter in a word or even the next word in the sentence.
You're absolutely right. And Shannon actually quantified that. His work showed that English text is about 50% redundant.
Wait, seriously, half of what we're saying and writing is basically unnecessary.
In a purely informational sense, yes. We could theoretically delete half the letters and still figure out the message.
Which seems, I don't know, inefficient, right? Like,
Right.
wouldn't a language with less redundancy pack in more information?
Here's the thing, and this is where it gets really cool. Think about all the noise and interference that disrupts communication every single day. Typos, slang, accents, background noise.
Don't forget bad cell reception.
Exactly.
Yeah.
All of that gets in the way. But this redundancy, even though it seems wasteful on the surface, it actually makes our communication incredibly resilient. It's like our language has this built-in error correction system.
So it's like our language evolved to be understood, even when it's not transmitted perfectly.
Exactly.
That's amazing. But it makes me wonder about something. Where does meaning actually fit into all of this? Like, we could talk about transmitting information, but that doesn't mean the receiver understands what they're receiving.
Yeah.
Like, my phone can transmit a bunch of ones and zeros, but it doesn't actually understand what it's sending.
You've hit on a really crucial point, and this is where some of the more recent research comes in. While Shannon was a genius when it came to the technical aspects of information,
Right, like how to measure it, how to transmit it.
exactly, but this whole question of meaning, of how we go from those signals to actual understanding, that's where things get even more complex. And that's where researchers like Corminus Murtra, Fortuny, and Sol are trying to take things to the next level.
It's like the difference between a robot that can perfectly mimic human speech sounds and a robot that actually understands what those sounds mean. Those are two very different things.
That's a great way to put it, and that's exactly what they're grappling with. How do we bridge that gap?
Exactly. They call this consistent information. It's not just about those bits, those ones and zeros, being transmitted accurately, but making sure they're actually decoded with the intended meaning on the other side.
Like
Like, we
that.
don't just want the message to arrive, we want it to be understood.
So it's not enough to just get the data there. You have to make sure the recipient is actually understanding the message the way it was meant to be understood. It's like, imagine trying to teach a robot about the concept of fire, right?
Okay, yeah, I see where you're going with this. Like, it's more than just showing it a bunch of pictures of flames and saying, fire, fire, fire. You want the robot to actually grasp the concept of fire, what it is, the fact that it's dangerous, how it behaves.
Precisely. It's a huge challenge, right? Because meaning, unlike transmitting a series of symbols, it's inherently subjective and dependent on context. What fire means to a human while they're cooking is vastly different from what it means during a forest fire. So how do you go about, quantifying that kind of information?
It's crazy how a single word can have all these different meanings based on something as simple as like the tone of voice or even an emoji.
Precisely. And Corminus Murtra, Fortuny, and Sol, they argue that for this consistent information to work, both the sender and the receiver need to be on the same page about what their signals represent in the real world. They actually draw on the work of this linguist, Ferdinand de Saussure. He talked about this duality that's inherent in any sign.
The duality. Okay, break that down for me.
So a sign, like a word, has two sides, right? You've got the signifier, which is like the actual, sound or image of the word itself. And then you've got the signified, which is the actual concept it's pointing to.
So to use an example, the word tree is just a bunch of sounds until we mentally connect it to like the image of an actual tree in our minds.
Exactly.
Okay, I'm with you. But how do they propose we actually measure this consistent information? I mean, it seems kind of slippery, right?
Well, their argument is that you have to factor in not only the probability of a message being transmitted accurately, but also the probability of it being correctly interpreted. They've even started to apply this concept to the evolution of languages.
Oh, really?
Yeah, like how this drive for consistent communication might actually be shaping the way languages change over time.
That's wild. It's like language isn't just this static thing. It's constantly evolving to make sure we can still understand each other.
Exactly. And it's all driven by this need for shared understanding.
This reminds me of, there's this study I read about where researchers were trying to get robots to develop their own language.
Yeah.
Like, they started with these basic sounds, but the crazy thing is, the robots actually started creating words with consistent meanings. So they could, like, work together to get stuff done.
That's fascinating.
Because, like, even robots are hardwired with this need for shared understanding.
That's a really important insight. This drive for shared meaning, it's not just some abstract idea. It's fundamentally woven into how we operate and evolve, and maybe even how other intelligent systems like robots operate and evolve too.
It's pretty mind-blowing when you think about it. This whole idea of information transfer, it's everywhere. It's how DNA replicates itself. It's how we communicate complex ideas. It's everything.
It really is, and it highlights that crucial distinction between simply transmitting information, those bits and pieces, and conveying true, consistent meaning.
So how do we prevent our robots from ending up just like spouting off a bunch of statistically perfect gibberish? What are the practical steps?
That's where things get even more interesting. Corminus Murtra, Fortuny, and Sol, their work suggests that we might need to shift our focus away from solely maximizing information transfer.
Instead of just like cramming in as much data as possible.
Exactly. They're saying we should be aiming to maximize the transmission of consistent information. This means we need to start designing systems that don't just transmit signals accurately, but also incorporate mechanisms that actively align meaning between the sender and the receiver.
So it's like, instead of just teaching a robot the dictionary definition of fire, we need to teach it all of the cultural and experiential context that gives that word its full meaning. Like we would just hand a toddler a lit match and say, here, learn about fire.
Precisely. It's about building a shared understanding of the world around us, which is way more nuanced and complex than just, transmitting ones and zeros. And here's where it gets really interesting. Their research actually suggests that this consistent information might represent less than the total information being transmitted.
Hold on, less information. How does that even work?
Think of it this way. You could transmit a message perfectly in Morse code, right? But it would be totally meaningless to someone who only understands semaphore. It's not just about the clarity of the signal, it's about having that shared code book.
That's a great analogy. So even if certain information is transmitted perfectly, it's basically useless if it's not being interpreted consistently on the other end.
Exactly, and that's why this research is so fascinating. They're basically suggesting that maximizing consistent information might require, filtering out some of the raw data, focusing on only the information that contributes to that shared understanding.
Wow, so it's not just about transmitting more, it's about transmitting smarter. This has been quite a journey so far. We've gone from the very basics of how we measure information to this much deeper question of what it means to truly understand something.
And it all goes back to that, deceptively simple yet profound question that Shannon posed. How do we actually quantify information?
A question that has led us down this rabbit hole into a field that's still evolving, still challenging everything we thought we knew about how we communicate, how we learn, what it means to truly share meaning with one another.
And as we move toward a future where we're interacting more and more with artificial intelligence, wrestling with these questions of meaning and consistent information, that's only going to become more and more critical.
It's like the robots are forcing us to define what it means to be human.
In a way, yes, but it's not just about robots. It's about understanding the very essence of communication itself.
This deep dive has been incredible. It's given me so much to think about. It really is amazing to think about. And, as we kind of delve deeper into this world of artificial intelligence, I can't help but wonder, how do we actually make sure that we're not just creating machines that can, spit out information, but machines that actually understand?
That is the question, isn't it? The million-dollar question. And it brings us right back to this whole idea of consistent information. We can't just feed AI tons and tons of data and hope for the best.
Right, like crossing our fingers and hoping they become sentient.
Exactly. We've got to find ways to actually teach them, not just the what, but the why. The underlying meaning and context that gives information its real significance.
It's how do I explain this? It's like the difference between, say, teaching someone the rules of grammar and expecting them to write a novel versus immersing them in literature, exposing them to the nuances of language, the emotions behind the words.
That's a fantastic analogy. We need AI that doesn't just process language, but actually understands those subtle cues, the implied meanings, that shared cultural understanding that we as humans just kind of have.
It makes you appreciate just how complex human communication really is.
Absolutely. And it makes this whole challenge of creating AI that truly gets us, well, it's incredibly daunting, but also incredibly exciting.
It really is.
Yeah,
And it feels especially relevant right now, with AI becoming so prevalent in our lives. It's like we've entered this new frontier of communication where we're not just talking to each other anymore, but interacting with machines that are trying to understand us on a deeper level.
And that's where things get really, really interesting because it forces us to examine our own communication, our own understanding of meaning. It's like in trying to create AI that truly gets us, we inevitably end up learning more about ourselves in the process.
Whoa, that's deep. It's like holding a mirror up to our own minds, trying to decipher the code of human understanding so we can then teach it to machines.
Exactly. And that, I believe, is one of the most exciting, challenging frontiers in science and technology today, this whole quest to bridge that gap between human and artificial intelligence.
Well, I have to say, this deep dive has been absolutely eye-opening. We've gone from the very definition of information, explored its weird relationship with entropy and redundancy, and arrived at this incredible frontier of consistent information and what it means for the future of AI.
It really highlights how, even though we've made incredible strides in understanding information from a technical standpoint, this quest to really understand meaning, to bridge that gap between us and the machines we're creating, well, it's a journey, and we're still right in the middle of it.
A journey that, as we've discovered, is as much about understanding ourselves as it is about understanding the machines. So listeners, as you go about your day, interacting with the world and all its information, just take a moment to consider, what does it actually mean to truly understand something? And how can we create a future where both humans and machines share that understanding? Thanks for joining us on this incredible deep dive into the world of information theory.